as back-end developers, we aim to make our APIs as responsive as possible. But what happens when our API solution is somewhat constrained by a long-running back-end process and we just cannot reply synchronously in a timely manner? Well, in today's video, we take a look at how you can get around that problem by adopting an asynchronous API pattern. Well, hello, wherever you are, whenever you are. Where am I? Melbourne, Australia, as usual. And when is it? It's February 2023. So yes, in today's video, we're going to be looking at a pattern, the Asynchronous Request Reply pattern. And the whole point of that is to, address the use case we talked about in the introduction, which is you have a long-running process somewhere in your platform and you're wanting to front that somehow with APIs, and we do not want to have the synchronous request response waiting for that long-running process. So let's just take a quick look at, again, what we're talking about really. I just want to do a bit of a demo just to get it really clear in everybody's heads, the problem statement that we're talking about. Now I have Insomnia here, my API client, and I have two endpoints. Now we're not building these endpoints today. This is purely just to demonstrate the problem statement. Now, the use case for today's video, or the sort of business scenario, is that we are engineers working on behalf of an online marketplace. Think of some big online marketplaces or online auction sites, and we're the engineers working for that platform. And we've offered to our consumers, to our customers, small businesses, a set of APIs that allow them to manage their products that they're selling on these marketplaces. So retrieving their products, creating products, that sort of thing. So here are two endpoints that we've given our consumers: get products. So if we just run that now, you can see it comes back within a few milliseconds. This is a synchronous request reply API, REST API, get request, super simple, nothing to see here. You've seen this probably a lot before, certainly if you've watched my channel before. So that's all cool. But let's flip the script a little bit and let's talk about creating products on the marketplace. And the engineers have given us this endpoint, and it allows us to pass over a payload of product details. So we're wanting to create thousands of products on this marketplace. Okay, we've only got two here, very simple, but imagine this was much more complicated object structure and tens of thousands of them. My question to you is, as a consumer of this API, would it be reasonable to expect to pass 10,000 products to this API and expect it to come back in 10 milliseconds and say your 10,000 products or your 100,000 products have been created? In my mind, that's not a reasonable assumption. There's going to be a long-running process that's going to have to create all of those products. So the synchronous approach is really not going to work. And let's have a look at what that might look like if we did try and do it synchronously. Let's click send. You can see that it's just going to hang, okay? And you can see the second timer counting up. This will reply in 10 seconds. That's the way I've designed this endpoint, just for demo purposes. And 10 seconds is maybe okay if it was a system to system type interaction and there was no human interactivity required. Might be okay, but again, imagine this was not 10 seconds, but 10 minutes. 10 hours, right? So you would not want to adopt the traditional synchronous approach. We need to think of other ways of doing this, designing our system. All right. Now, that's what we're going to do today. So hopefully you understand the problem statement. We need to get away from hanging, waiting for long-running processes. Now, just before we move on to looking at a few approaches you could take, we're going to focus in on one today. I just want to clarify one other point. I'm sure I don't need to clarify it, but I'm going to say it just anyway. This is the endpoint for retrieving those products that we just used there. And it's just very simple. It's using a database context to pull products from a small database. I'm using the async await keywords here. So in today's video, we're not talking about this. We're not talking about using well, we will actually use async await, but that's really not the subject matter of today's video. Async await in synchronous programming in C# is all about thread safety, certainly when you're talking about API endpoints. What it means is if there is a long-running process, using async await will return the thread to the pool until that process comes back. So it avoids things like thread exhaustion. So it's more about making your APIs scalable, but it's not at all what we're talking about today. This endpoint is still a synchronous endpoint, okay, when we call it as a client. So hopefully that's clear, and I just wanted to clarify that's not what we're talking about today. Fantastic. So just before we start coding, what we're going to do next is we're going to look at some approaches you could take to making your API layer decoupled from your long-running processes. And again, we're going to focus in on one of those today. So let's take a quick look at those before we start coding. Just before we move on with the rest of today's video, if you do like it, please consider giving it a thumbs up, giving it a like. It really just helps me out. And if you've not done so already, maybe think about subscribing, ding the bell, and you'll get notified of all the new stuff that I make. To be honest, I only make about 6 videos a year, so you're not going to get bombarded with lots of annoying notifications. Now, if this announcement is of itself annoying, I do apologise. We'll be getting on with today's video in just a minute, but if you do find it annoying and you want to avoid adverts and announcements like this, then maybe check out my Patreon channel, where you'll get all my YouTube content for a very small monthly fee, but with absolutely no adverts. Anyway, enough of this, let's get back to today's video. So let's take a look at 3 approaches you could adopt to address this whole problem with long-running processes. And we're going to go through each one of these in a bit more detail in just a bit, but just to kind of give you the high-level overview, the 3 approaches are the Asynchronous Request Reply pattern, and this is what we're covering in today's video. This is what we're going to implement in today's video. More details in just a second. Second approach, which we're not implementing today, but we will talk about a bit, is callbacks or using webhooks. And the third one is to use a persistent connection between the endpoints. Okay, now 1 and 2 are really just relying on standard HTTP request responses. Number 3 is actually going to utilize something called websockets, or if you want to use the Microsoft flavor of websockets, something called SignalR. I've done a video on websockets and SignalR if you want to check that out and understand how they are, how they work and what they do. Again, we're not going to implement that in today's video, but we will have a quick slide on how that may work. So let's look at them in a bit more detail. So this is the first one we're going to implement today. And as you can see here, we have the client. This would be the Insomnia client. And then we have 3 endpoints that we're going to stand up today. Now the first one is the starting endpoint, and this is where our client will start its journey, and it's going to post its 10,000 products to this endpoint and go, I want to create these. The start endpoint will reply with a HTTP 202, and 202 just is the accepted code. Okay, so rather than a 201, which is created, saying that your resources have been successfully created, a 202 is just saying we've accepted your request, nothing more. And along with that reply, that 202 reply, we will send a reference number, a tracking reference number that we will use in just a bit. We will send back the URL of a status endpoint that we will use to, no surprises, understand the current status of a request. And then thirdly and optionally, I like this though, an estimated completion time. So this is somewhat a polling solution, as you'll see in just a bit. I don't love polling. It's sometimes necessary, but wherever possible, I want to minimize the amount of polling requests. So I think by sending an estimated completion time, going, look, don't even call the status endpoint for at least another hour, I think minimizes that redundant pinging, polling, status checking, which is what the client would do next. So it will then use the status endpoint that it was given and pass over the reference number to check to see what is the state of my 100,000 products being created. And that is now just a pinging back and forward. So you might want to do that every 5 minutes or whatever. Eventually, the products will be successfully created, or some of them will be created and some of them will have failed. Nonetheless, the process will have completed. And there's 2 ways we could then work with that. We could, in the final ping to our status endpoint, just reply back to the client with a third endpoint, the final endpoint, saying, here's the endpoint you can go and get all your products from. Or, as we're going to do, when we make our final call to the status endpoint and the job has been completed, we're going to respond with a 302, which is a redirect, and we'll just automatically redirect the client to the final endpoint, and we get all our products or whatever it is we decide to do. So that is the synchronous request reply pattern. And as you can see, it is still made up of multiple synchronous HTTP API REST type requests. Okay, we just get more of them, but the way we've structured it means that we are not, I mean, we're still waiting. There's no getting around waiting for something, but we're not maintaining a HTTP connection. All right, so that's the pattern we're going to adopt today. Second approach is to use webhooks or callbacks, whatever you want to call them, reverse APIs. Webhooks are also called that as well. And this is the way I would see a webhook type solution working. The client will post to the start endpoint exactly as before. It will give that endpoint its 10,000 products. Along with that, though, it will also give to the e-com platform our endpoint, our webhook endpoint that we can be reached upon when the product creation process has completed. So it's like phoning somebody, them saying to you, I'm too busy, we'll call you back, give me your phone number. It's exactly the same principle as that. So again, as before, the start endpoint will reply, going, yep, we've accepted your request. It's not been completed yet though. The process will, run obviously. I'm just saying at this point in time, we will have some kind of callback service. So there's going to be some service that's going to be responsible for calling us back, and it needs to be aware that there's a job. And in this instance, I'm just saying the start endpoint communicates with it somehow to say, we've got another job, get ready to call it back. So there probably is some other actors, to be honest with you, on this slide. The actual processing job probably needs to talk to the callback service, but I don't have that one here. I'm sure you can use your imagination. What is the most important part of this whole schema here is that we will have to stand up, as a client, we will have to stand up a webhook endpoint. And this is the URL we gave to the start endpoint right at the start of the flow. And when the product creation process finishes, the callback service will call our endpoint with the result. And we should reply back to the callback service to say, yeah, we got that as well. So kind of, yeah, reverse API is probably quite a good term for webhooks. Now, I really like webhooks, but as you can see here, it does require more engineering on the part of the client. Okay, so in the first pattern, the async request reply pattern, all the client has to do is call the APIs. In this instance, it has to also supply an endpoint. And some people are resistant to that for some reasons. Effort mainly, cost, things like that. Sometimes security gets raised because you're opening up an attack surface and all that kind of stuff. But I really like webhooks, and I think if they're engineered well, then it's a really good option. But we're not covering it today. I do have a course on lesjackson.net that covers building a webhook solution. So if you're interested in that, go and check that out. And then the final approach, this is super simple by the way, is just to have a persistent connection between the two endpoints, okay? And I've been deliberately a bit facetious here, and I've not kind of gone through sequencing, because really you just have this persistent connection. When you're using webhooks or something, not webhooks, when you're using WebSockets, there is a bit of negotiation to set up a WebSocket connection, which I've not put on here. I've just put the persistent connection. And what it means is both endpoints can just talk to each other as and when they like. You've got this established connection. Definitely an option. I don't see it being used as much outside of maybe private, APIs. Don't see many people offering it to like public consumers. So it's possibly an option though. But again, we're not going to cover it today. If you are interested in webhooks and SignalR, I do have a video on the channel that covers it. All right. Enough of this theory. Now we're going to jump into coding, and we're going to code up the synchronous request reply pattern. So let's get started with coding up our solution. And actually, just before we do that, I promise you this will be very quick. I want to draw your attention to this article that Microsoft have written on exactly the same subject matter, asynchronous request reply, and they do a good job of going into a bit more background than I have on why you might want to use it. They are coming at this very much from an Azure perspective, so they actually provide code and all that kind of stuff on GitHub as well. And this is kind of how they are going to implement it, and they make use of message queue, message bus, all that kind of stuff. What we're doing is we're not using Azure, we're doing all this locally. For me, I feel it makes it a bit more accessible to everybody. And I did think about employing or writing like a process worker that will actually, you know, process these theoretical products and then flip the status switch from, you know, in progress to completed. But I actually just thought that was a bit of a waste of time doing that. So I'm just going to do that role manually myself, and really we're just going to focus in on the API part of it. Okay, so hopefully that makes sense, and I'm not doing a lot of this extra stuff. But point I'm making here is if you want to check out how you might want to do it on Azure using Azure functions and stuff like that, there is a great article here. I will put a link in the description below if you want to follow along with that. So anyway, let's get going with coding. Finally, we'll open up a new Visual Studio Code window, pull it onto the screen here, and do a control and backtick to open the integrated terminal. And the first thing I want to do is actually just check that we've got .NET Framework installed. So .NET -- version. I'm sticking with version 6. Version 7 is obviously out at the moment. I'm sticking with 6 as the long-term support version. But if you want to use 7, you should absolutely be able to do that with no issues whatsoever. I'm going to now change into my working directory, which is on my D drive. It's in my episode, no, it's in my season 6 folder, and it's in my episode 2 folder. Shouldn't be anything there. Cool. And then I'm going to do a .NET new. I'm going to create a web API. It's going to be a minimal API. And we'll call it, yeah, as we've got there, async product API. Okay. Hit enter. That will go away and scaffold that up. Do a quick directory listing. Fantastic. We will change into that folder. Wonderful. And we will do a code.-r to open it recursively in the same instance of Visual Studio Code. And it's just asking me, do I trust myself? I do trust myself. So I'm not going to go through what a minimal API is. I've got a dedicated video on the channel about minimal APIs. That's a good point though. I'm going to take some shortcuts here in writing up this API. I'm not going to follow best practices, so I'm not going to use a repository, which I usually would. I'm going to directly use the database context. We're going to use DTOs, data transfer objects, a little bit, but not employ them fully and properly. And related to that, I'm not going to use something like AutoMapper to map between our models and our DTOs. Again, if that's all kind of what you're talking about, check out the minimal API video I've got here on my channel. We're going to do some of it, but not all of it. And the reason I'm shortcutting it a bit is time, okay, just to try and keep my videos a bit shorter than they have been, okay. So I will call out where I'm not following best practice, but for today's video, it should be okay, I think. All right, so just before we move on with anything else, what I want to do is come into the program class, and I want to just clear out a lot of the templated code. So if you just follow along with me, I'm going to take out this stuff related to Swagger, leaving line number 1 and line number 5 as it appears here now. I'm going to take out this block as well. We'll leave in HTTPS redirection. I'm going to take out all of this stuff. Make sure you leave in the app run though. And I'm going to take this record out as well. So we're going to really have it super minimal. We should only have 4 lines remaining, like so, okay? Make sure you save that off. I'm going to come in to the properties folder, open launch settings JSON, and I'm going to take out a couple of lines from each of these profiles here. So launch browser and launch URL, take that out from here, and I'm going to take it out from here as well, okay? And leave that like that, okay? But make sure you've got the application URL here, and these will be the endpoints that will actually get spun up, okay? So save that off, don't forget to save that. And then we're going to add a couple of package references. So just open your CS proj file, And I'm actually going to take this out because we don't need this. I'm just going to manually delete that. Don't need that, save that off. And then I'm going to open up the command prompt again, so control and backtick, and we'll install a couple of packages. Now we're going to use a database in today's solution. We're just going to use SQLite. Super easy. I'm actually really starting to love SQLite. It's just nice and easy to set up. Don't have to worry about anything else. So in order to do that, we're going to add a couple of packages. So the first one is Microsoft Entity Framework Core SQLite. So .NET, add package. Actually, we do need to add this one as well. So the new instance of PowerShell kind of remembers things you've typed in before, which is wonderful. So it's remembered I have previously installed this package. So I just kind of quickly auto-completed it, which was great. And the package is Microsoft Entity Framework Core.design. So let's install that one first. Doesn't really make any difference which one you install first. Okay, you can see it appear here. And then if you just do an up key, actually, let's clear the screen. Do an up key, we'll take out design and we'll put in SQLite. Hit enter, and that will also get added. And those are the two packages we need. Fantastic. So that's our basic sort of scaffolding done. We'll maybe take a little breather here, and then in the next section we'll move on and start creating our models and stuff like that. But yeah, we'll take a quick pause here before we move any further. So in this section we're going to wire up our data requirements, and that will start with creating a model. So over in our File Explorer, right click, new folder, and we'll call that models. And into our models folder, you're going to create a model called listing request. And you might be going, what is a listing request? Well, just coming back to our schema, our interaction diagram, when our client posts a request to the start endpoint, basically what it's requesting is that products are listed on this marketplace. And that's why we're calling it a listing request. And it's really, for the most part, certainly as far as our client is concerned, is only going to contain the list of products that we want to create. Now, we're not actually doing that much with that list of products. It's just for illustrative purposes, but that's really why we're calling it listing request. Now, it's good. This model is going to contain a few other things as well, but we'll cover those as we get to them. So first of all, we'll declare the namespace, and it's just the name of the project. So ASYNC product API. Ironically, I have issues spelling async. I almost put a H in it for some reason. I don't know why I do that. Anyway, and that's models. Okay, cool. And it's just a public class called listing request. Okay. Now we'll declare some properties, so you can just type prop and tab. This first one is an integer, and the first one, no surprises, is just going to be an ID. And we will migrate this model down to our SQLite database. This ID effectively will be the primary key in our database table. So I'm not really going to do too much more with that though. Next thing we want, next property, is a string, and we'll call that request body. And as the name would suggest, this is literally going to be the body of the HTTP post request, which is going to contain the product list. Okay. Now, I'm just going to put a question mark in there just to say that it's not null. Okay. And so this is our client's going to pass that stuff over. Now, a bit of data we want to pass back to the client when we successfully, create this request. Do another prop. I did mention this before, is this estimated completion time. Okay, and the idea here is that when we make a request, we're going to tell the client, look, don't try and call our status endpoint until in and around this time when we estimate it to have completed. Other than that, you're just going to be doing redundant pings. Now, this does raise an interesting point that we are going to expose this model through our API endpoint, through our post endpoint. So theoretically, it could mean that our client could provide us this information. We want to pass this back to them, and we're using this model as the vehicle to do that. So this is really this whole debate around using DTOs. Really what we should be doing here is having a couple of DTOs. One DTO for the inbound path, where they literally just provide this stuff, and then another DTO for the outbound path, where we provide back this and a few other bits of information. But again, for quickness, I'm just not doing that today. If you want to see how to do that, then yeah, check out my other video on minimal APIs. And we do want a few other bits, a few other properties. So another string. The other thing we want to pass back is the request status with the request. And we also want to store that in our database, of course, so that's why I'm putting it in here as well. And then perhaps most importantly, another prop, string, we want to have our own request ID. And this is going to be the ID that we use to track the status of our request. You might be going, well, couldn't we use the primary key of the table? We could do that, but since it's a very simple ID, certainly in the case out of the box with the way we're going to use it, it's just going to be an integer that increments with each new insertion. It's probably not a great idea to use that just for security reasons. People could start guessing IDs and doing brute force attacks and stuff like that. So we're going to generate our own unique request ID that should be globally unique. And the way we're going to do that is by using a GUID. So new GUID to string, like that. Okay. And you can see here we don't need to put a question mark in here because we're actually assigning this a value. All right. So that's our model done. And this will get migrated down to our database. And again, I will just call it again, we should probably be using DTOs here. We are going to use a DTO a little bit later, just in a slightly different part of our solution, and you'll see what I mean by DTOs. But for now, I think we just leave that as it is. So next thing we want to do is just a DB context. And again, the DB context is responsible for mediating this model down into our database. Very standard entity framework core stuff. So new file, app.db context.cs. So provide a namespace as before. And it's just async product API, this time it's .data. And it's just a public class called app.db context. But we're going to make use of a base class called db context. Just make sure you get the capitalization of the B correct. It's a lowercase b. To bring in the namespace for that, so control period with your cursor in the offending article, we'll bring in entity framework core. And we want to give our class a constructor, so CTOR tab, and into that we're providing some DB context options. And what is that type? Well, it's the type we're declaring here, so app DB context. We'll call that options. And we'll just pass that through if we have a base class of that, so options like that. And we can just leave that as it is. And then to round out our DB context, we just need to create a DB set. So DB set of type listing request. And I won't know what listing request is at the moment, but we'll let that complain in just a bit. And we'll call that listing requests. And we'll just set it to listing request like so. And it should just complain about what listing request is. So cursor in the offending article, control the period, and we'll bring in our model's namespace. Fantastic. All right, so that's our DB context done, but we do need to register it in our program class just for dependency injection. Okay, so we're in the program class, we'll access our builder, we'll access our services, and we're just going to add a DB context. Try that again, DB context, that's better. And of what type? App DB context. Fantastic. And then we'll just pass through some options. So OPT goes to, don't forget the head there, OPT, use SQLite, and I won't know what SQLite is. Just capitalize the S. It still won't know what it is though. And into that, we just pass the connection string. Connection strings for SQLite are pretty simple, so I'm just going to put it directly in here rather than putting it in config. And it's simply data source equals whatever the database name is. I'm just going to call it requestdb.db. And we'll run that out like that. And so it doesn't know what our DB context is, so control period to bring in the namespace for that. And it doesn't know, oh geez. It Let's try that again. And then it doesn't know what SQLite is. Let's bring that into. Fantastic. So that's basically our DB context stuff done. And again, just to reiterate, our DB context contains our DB set of listing requests. So all that remains to be done is to perform a migration. And the first thing we need to do is generate our migrations. So .NET EF migrations, you can see it there, add, and then you just give your migration a name. So I'm just going to call this initial migration. Okay. And I can't remember if it complains if you have a capital letter anywhere in the name of the migration. I'm not sure. Let's give that a go and we'll, should be okay. And what that will do is it will generate a migrations file in a migrations folder up here. As you can see, that's just been created, and that just has a list of instructions for how the table needs to be created. Okay. And then all we need to do is clear the screen is to do a .NET EF database update, and that actually applies the migration. And what we should see if it's successful is a database file being created down here. Indeed we do, called requestdb.db. That's just our SQLite database. Now I am going to access the table at some point just to basically change the status of our request when we come on to doing that. And in order to do that, there's a number of things you can do, a number of ways you can do that. I'm going to use a tool called dbeaver, which I just really like. It's a sort of multi-database, cross-platform tool. You get it on Mac, you get it on Windows. I think you probably get it on Linux as well. And it just allows you to connect into different databases. So you can see here, SQLite. We just browse to that. So I'll go down into my, I think I was already there. E2 into a project folder and just open that up. And we should be able to see the table that's being created here. And you can get extensions for VS Code if you don't want to install this tool, but I really like it. It's free, you get it from the Microsoft Store in this case if you're on Windows. Yeah, it's a really nice tool, and you can see we have our listing request table there with all the columns that we need. So that's looking pretty good. So we'll maybe take a little bit of a breather there, and then we're going to start moving on to our endpoints next. So in this section, we're going to begin and wire up our first endpoint, the start endpoint here, which is a post endpoint that responds with a HTTP 202, an accept response message. So let's get started. So back over in our program class, just after the use HTTPS redirection, we're going to start with this endpoint. So I'm going to label it, just so we kind of know what it is. And we'll use map post, and into that we will provide the route to this endpoint. So API v1 products. This can be anything you like, of course. It's going to be async, as we're going to be using some of the asynchronous database methods, and therefore into that we provide an app DB context, and we'll call that context. And we're also going to expect a model, a listing request model in the body payload. Now again, we are only expecting from our client, we are only expecting this as an inbound parameter. This other stuff we are not expecting from them, and that is again why we should really be using a DTO here, just to expose this property to them. This is stuff that we will pass back to them, okay? But I'm just shortcutting it a little bit by directly using the model. So put that in, listing request, and we'll call that listing request, and then we'll just finish off our method signature before we complete it. So it doesn't know what this is, so control period to bring in our models namespace, and let's get going with the body of our method. So the first thing we really want to check is to make sure that this listing request object is valid, and I'm just going to keep it really simple and say if it's null, then we'll just return a bad request. So return results bad request, which I think from memory is a 400. Okay, but assuming that's okay, we can keep going. Now again, as I've said, we want to pass back some data to them using this model. So we want to pass back the status, which we're going to set now. We also want to, well, we want to pass back this, but this is taken care of us already because we're creating the GUID here. But we also want to pass back this estimated complete time. So I'm going to do those two attributes here, those two properties here. So we'll say listing request status equals accept, or in progress, or whatever you like, something to denote that it's not actually completed. And then estimated complete time, so listing request, estimated complete time. Again, you would have a method here that would derive that for you based on some algorithm, you know, how many products were passed in, how many people were ahead of us in the queue. You would also, again, coming back here, probably not use a string to contain it. You could do, but you probably use a date time. But I'm just using a string because I'm going to manually hard code it, again, just to illustrate the point. And let's see, 2nd of February, well, it's February the 6th, and then we'll just say at 2 p.m. So we estimate it will complete around 2 p.m. So you might want to start checking the status endpoint maybe a bit before this, something like that. Anyway, next we want to save off this request into the database so we have a record of it, as we will be using it a bit later. So wait, context, and we want to find our listing requests, and it's not picking it up. So let me just, did I declare the DB set? Ah, okay. I need to make this public. Public. Okay, that should expose this now. Let's just try that. It does, there we go, that's much better. Okay, so context listing requests, add async, and we're just going to add in our listing request like this. Okay, fantastic. And then we will save those changes down. So wait on context, save changes async like that. Perfect. Okay. And then the only thing that remains to be done here is actually to generate this HTTP 202 response. So the way we do that is return user results. And this time we use this accepted method here. Okay, so if you watched any of my other videos, I would more than usually, if it's a post request, we're directly creating resources synchronously, I would use created. But again, this is an asynchronous method, so we're going to use accepted. But the method signature is very similar. So we come in here, you can actually see what it's expecting. So it's, the first thing it's expecting is a string, a URI, and you can see here it's the URI with the location at which the status of the requested content can be monitored. So this accept method is custom built for what we are attempting to do. It's exactly designed for our purposes. So we just want to pass in the status URL, okay, of our status endpoint. So I'm just going to say API v1, I'm going to call it product status. Okay, but we also do want to provide the ID of the status request, of the request itself. So I'm going to use string interpolation to do that. So we can back over here, put a $sign in here, and I'm just going to pull out the request ID of our listing request. So listing request, request ID. Okay, and then I'm also going to pass back the resource that we created, which was just our listing request. And again, you would typically want to probably use this, put a DTO here, but again, for what we want to do, it's fine. All right, so again, you'll remember, let's just have a quick look at this. When we respond back, the client will want to hit the status endpoint, and we are getting that status endpoint as part of our HTTP2 response. And you'll see how that looks when we actually test this now. All right, so let's save that off. Let's bring up a command prompt. Let's do a .NET build. Excellent, let's do a .NET run. Fantastic, I'm going to copy the HTTPS endpoints. Copy, and I'm going to bring up Insomnia, which I'm going to use to test our endpoint. Pull that onto the screen, like so, make that full screen, and I'm going to create a new request. So up here, new HTTP request, I will rename this and call it create product listing. Okay, it's a post request. I'll paste in our URL, and then the endpoint is API v1 products. Okay, so again, just to clarify what we are hitting this endpoint here. Okay, fantastic. And then we just really expect a body of requests, okay, or products more correctly. So curly brackets, what was it called in the model? Let me just go back here. So back down here, we are really just wanting this request body. So request body. And again, you would possibly want to make this a lot more complex. I'm just saying it's going to be a whole big blob of JSON objects. You may want to have this, you know, a bit more granular and actually have JSON attributes in here. I'm not doing that because we're not really doing anything with this anyway. So let's just send that. Okay, excellent. We get a 202 accepted, which is exactly what we want, and we get the resource passed back. So we've got a request ID, which we're going to use a bit later. We have the status, we have our estimated completion time, we return back a request body, which again, using a DTO, you might not want to return that back. But more importantly, over in headers, you'll see the location is basically the status endpoint, and it's also baked in the request ID that we need to use. Okay, so this is the status endpoint we will actually write in the next section to allow us to check on the status of our request. So we'll maybe take a bit of a breather and then we'll move on to doing our status endpoint. So we want to move on now to our second endpoint, which is our status endpoint. So just a quick recap, this one here. Okay, so in our start endpoint, we are passing back the route to this endpoint that we're going to implement now, and it's just a get endpoint, initially responding with a 200 just to give us the current status of our job. Now, just before we actually get going with creating that endpoint, I actually want to make use of a DTO here, data transfer object, because actually I shouldn't get rid of that. The data that we are passing back here from our status endpoint, I just want to pass back a few bits of information. Firstly, and most obviously, the status of our request. I also want to pass back an updated estimated completion time because it could change, so it might be useful to pass that back. And then finally, when we actually get to the point where the status changes from accepted or in progress or whatever we called it to completed, I also want to pass back the URL of our final endpoint. Now, ultimately, we're going to just do a redirect to that endpoint, but initially, we're just going to provide this endpoint detail as part of this request. So I want to provide those things back. And in order to do that, I do want to just construct a DTO to contain that information. So back over in our project, I want to create a new folder for our DTOs. So new folder, I'm going to call it DTOs. And into that, I'm going to create a new DTO called listing status.cs. Okay, so namespace as usual, async product API, DTOs. It's a public class called listing status. Okay, very simple class with 3 properties, all of which are strings. And the first one is request status. Excellent. The next one is also a string, and it's just going to be estimated completion time, an updated estimated completion time. And then the last one, also a string, is just our resource URL. Okay, and the resource URL is just basically the URL to our final endpoint. And this final endpoint is basically I guess what we were after all along, isn't it, really? So instead of we made a synchronous request and we got back exactly what we needed, it's the resource URL that's giving us that thing that we wanted in the first place. So it's the final link in the chain of our asynchronous request. All right, so let's save that off, come back over to our program class, and we'll get started with our status endpoint. So I'm just going to label it status endpoint. Use of app, it's map get. And into that we pass the route to our status endpoint, which I'm going to copy from here, as this is what we're passing back from our first endpoint. So we definitely want to make sure it matches, but we also do request or require a request ID. Like that, okay, as part of the route, as we need to know what the status of our particular request is. All right, and then it's not going to be an asynchronous method, this one, but we do still require an appdb context. For context, and we're also going to expect that request ID. And again, the minimal API is smart enough to kind of try and understand where this request ID is coming from. Up here in this post request, it kind of guesses that the model, this listing request model, is coming in the body. Down here, it will basically understand that this request ID is going to come in the query string of the GET request. And you can see that's how it's been passed up over here. All right, hopefully that made sense. And let's just do the body of our method now. So the first thing we want to do is try and get the object from our database. So I'm going to create a listing request object and user context, go to our listing requests and get a first of default. And we'll do a little query using a lambda expression. So listing request goes to listing request, and we're going to look for, I want that to be LR, not LT. Listing request goes to listing request, and we are looking for our request ID. I'm going to check to see whether it's equal to the request ID that was passed in our query string. So this value here, basically. So at this point, the listing request is either null or we have something. So if it's null, we don't really want to do much else, but let's just check it first. Listing request equals null. Then we'll just return results, and we'll just return a 404 not found, like this. Cool. Assuming we have something, then we want to do something with it. And this is where I'm going to make use of our DTO. So I'm going to create an instance of our DTO. I'm going to call it listing status. And I don't think we'll have the namespace for it, but that's okay. We'll bring that in. Let's just bring that in now. Listing. Yep, bring in our DTO space. So listing status, we'll call it listing status equals a new. Put a minus sign in there. I was wondering why it wasn't resolving for us. There we go. New listing status. Excellent. And I want to populate the status from our listing request. So we say request status equals the listing request we've just pulled back from our database and whatever the status of that was. And at this point in time, I'm just going to set the resource URL to an empty string, because we don't have it yet, okay? But we will tackle that in just a second, okay? So that's us set up our listing status that we're going to pass back. But now we do want to check. We're going to say if the listing request, if the request status, and I'll just convert it to upper. And again, this is, I don't particularly like using sort of magic strings here, but I think in this case it's kind of okay. If it's equal to complete, so our job has actually completed, then we want to additionally pass back that resource URL. So our listing request, sorry, our listing status, not listing request, listing status, resource URL equals whatever our resource URL is. Stick a pin in that for a second. And then we just want to return back results. Okay, with our listing status. Okay, so we've not quite done this redirect stuff yet. We will do in the next section, but for now we're just going to say if it's complete, we'll pass back the resource URL. What is that resource URL? Well, it doesn't exist as yet. We don't have that endpoint yet, but I'm going to say it's going to be something like API v1 products. It's going to be a GET request, and I'm also going to provide it an ID. So when we redirect or when we tell our endpoint that it can pick something up at this resource, we need to give it an ID for that job or whatever we want to call it. Now we could use the original request ID. I don't think that's a good idea. I'm going to actually give it a completely new ID. I just think that's better practice to do so. So with that in mind, string interpolation, and we're going to suggest that it's a new ID. So again, we'll use new GUID and toString, like so. Now this ID, as I'm sure you can appreciate, doesn't go anywhere, it doesn't relate to anything, it's just a new ID that we have generated. And again, you'd have that stored in a database somewhere and all that kind of stuff. As I said, I decided not to implement the job processing stuff, which is probably where this would come from. Okay, but again, this is going to only happen if our status is complete. If it's anything other than complete, then this is not going to happen. And so we just want to go back to our listing status object, and we're going to update our estimated completion time. Okay, and again, you know, this is just a bit of fun. Let's just copy this, saves me typing it. And let's say for some reason, we've gone, actually, this is going to take a bit longer than we initially thought. Don't come back until this time now. And we'll return, in fact, you can just return this same thing here. Excellent, so we can test this out now. Now you will appreciate that this clause here, we've not really finished our full build, we've not done the redirect stuff, but I do want to just test the logic before we move on to that last step. Okay, so let's just bring up our project, let's do a .NET build. Excellent, and let's do a .NET run. Let's pull Insomnia back onto the screen. And we'll create a new endpoint. So a new HTTP request. Let's get the route that we were passing by. Well, actually, we can get it from our response here in the header. Let's just copy that. And let's paste it into here. And we only need to get the full URL. Let's come back over here and get that from here. Now, we could actually inject this, you know, localhost and the port number into the response as well, and if I remember to do it, I will put that code on GitHub. This code is obviously on GitHub, but I'm just going to leave it off just now, just for quickness. And just make sure that route is correct. Okay, so it's a bit difficult to see on the screen, I apologise. So localhost is the same base route. We're going to product status, I'm going to check the status of our request. What do we get? We get a 200 OK, which is good. The request status is still accepted, and oh, we've got an updated estimated complete time, but we have no resource URL. Okay, so what I'm going to do is I'm going to come into dbeaver, I'm going to flip the status of that. Okay, so this step here is basically the step that would have occurred if we had written some kind of job processor or something like that. Let me just get rid of that. I don't think it's going to the right place. Let me just open up a new window. There we go. So select everything from listing requests. Let's just run that. It's in there. Okay, so we just want to update that. So we're just going to do a blank update. We've only got one entry in there. So update listing requests, sets request status. To completed. Was it complete or completed? I can't remember. This is the danger of using magic strings. Complete, as you can see here. That's cool. Probably should opt for like numeric codes or something like that, to be honest with you, but that's okay. Let's execute this just to flip the status. So again, imagine this is the job that's run. It's actually created our products and it's flipped the status to complete. If we then make a call using Insomnia one more time, we get our status of complete. We don't have an estimated complete time now, which is cool, that makes sense. And we have our resource URL passed back here that we can then hit, and it should be a GET request. All right, fantastic. So we'll maybe take a quick pause here, and then in the last section, we'll do two things. We'll stand up our resource URL, resource endpoint more correctly, and we'll also implement that redirect code, which is really, really simple. It's one line, but yeah, we'll do that in the last section. All right, so in this final section, we're going to implement our resource endpoint, our final endpoint, and we're also going to update our status endpoint to automatically redirect. So the first thing we'll do is our status endpoint, and this is super simple. It's not actually doing anything, to be honest with you. It is literally just something we can hit as an endpoint. So final endpoint. Okay, so app get request, so map get. And what is it? It's going to be this here, API v2 products with a request ID. So we'll just paste that in here like that. We'll say we expect a request ID as well. That actually needs to be in curly brackets, doesn't it? Otherwise we'll get an issue. Cool. Not an asynchronous method. We're not even using our database, so we don't even need a AppDB context. We just need the request ID. And we're not even doing anything, to be honest with you, with the request ID. We're not validating it or anything. As you can appreciate, we just kind of generated it up here as a new request. So it's not even existing in a database or anything. So really all we're doing is just returning a 200 at this point with whatever our final desired result is. So in here, this is, get caps lock on. This is where you would pass back the final result. Okay, so this is really, this endpoint is closing the loop on our whole request cycle, and it's whatever the final response would be. Would it be a list of created products or a report or something like that? I don't know. So it doesn't really matter. We just need an endpoint to hit. So let's just save that off. Let's just run up. And let's just test that endpoint. I mean, it's super simple, but I just want to test it anyway. So back over in Insomnia, new request. We'll rename it. We'll call it final endpoint. Cool. And it's got the same route as this, basically. Copy that and paste that in here. But we do expect some kind of ID. Again, just put any old thing in there and it should respond back with this is where you would pass back the final result. So again, coming back to here, I should actually rename that to status endpoints. Is that the right one? Create problems, new request, yeah. Should have renamed that status check like that. So when we hit our status check and we got a completion back, then yeah, this is passed back here. Now we're not passing back the full route, you know, including the server name and stuff. We could do that, and if I remember, I will put the code that allows you to do that on GitHub. But again, you can infer that quite easily anyway. So again, status check complete, gives us this URL. We come back here and then, you know, navigate to that. But what we want to do just to close out the whole thing is to auto redirect to this endpoint. So we don't even need to manually call it from here. So I'll close this down, get rid of that. And it's actually very, very, very simple. We just come back to this clause here within our status endpoint and we'll comment this out. And we will just return back, instead of a 200, we will return results, redirect, and we simply pass in the URL where we want to redirect to. So I might hard code in the first bit of it, which is really just our host name and the port. And again, you can get this stuff programmatically. I just, in this interest of time, I'm not going to put that in today. And then we just want to append on this resource URL that we've created here. So I'll put a / there, and we'll just go plus listing status resource URL like that. Okay, and that's us redirecting back here. That should work unless I've done something crazy stupid. So bring that back up, .NET run. So what it means is when we hit the status endpoint, do our status check, rather than getting this response, it's going to redirect us to here. Okay. Let's hit send. Indeed it does. This is where you pass back the final result. If we look at our timeline in Insomnia, you can see here that we hit our status endpoint, so product status, and then we get this redirect from Kestrel 302 to our, basically our final endpoint, okay? And that is our asynchronous API pattern. So I hope you enjoyed today's video. It was lovely having you here with me, and until next time, stay very safe. For those of you who are Patreon supporters, again, thank you very much to you as always, and your names are coming up next.